Hello and welcome to another developer toolkit. So this time around, we're taking a look at another component for a first-person style game, in particular in this case, a first-person shooter style game. So what we're looking at is when we've got a game where we've got a lot of different enemy characters in it, one of the things that can be a challenge there is being able to balance that experience for the player. So if we have a lot of a particular enemy present, and it's able to all be attacking the player, then that can become very rapidly overwhelming. So that can be a case where, okay, well, if we're going to be using an enemy a lot in a scenario, then maybe we need that one to have lower health. So it's really easy for the player to take them all out, or they can do very minimal damage. So you might sometimes hear that referred to as popcorn enemies, ones that you can just sort of get rid of really, really quickly. But then if we only want to have, 2 or 3 of those present, not, half a dozen or 10 or more, then it starts to get tricky to balance that. Do we have different variants for like, well, we're going to have this version when we're having a few of them, this version for when there's a lot. And so that can make it messy for balancing. But we can actually set up our AI. So our AI is being able to balance it. We can create a case where the player can be under pressure, but we're controlling the amount of pressure, and we're able to make it that not all of that pressure is real. And that's actually going to be what we're doing with this, is making it that while the player might be actually not under that much of a threat, they feel like they're under a lot more threat. So let's take a look at what we've got set up. So at the moment, this is what we've got. We've got this test bed created where we've got a few different enemy types. We've got a small, medium, large, and huge one. They fire, they do damage to the player. Depending upon the particular enemy, the projectile they fire is different, and it does different amounts of damage and different rates. And the player just keeps track of the amount of damage they're receiving. And it also has a vignette that the vignette increases in intensity based upon how much damage has been happening, so the average damage that's been happening recently. So what we want to do is we want to make this so that we can, regardless of composition, it feels threatening, but that the actual amount of damage happening to the player is more consistent. So, for example, at the moment with this sort of mix of ones, we want to be able to have it that whether we've got this mix, whether we've got a case of 10 of the huge ones or 50 of the small ones, regardless of what sort of composition we've got, we want to have a similar feeling for the player. So what we're going to do for this is we're going to set up so that we have a controller for the AIs. And in particular, in this case, it's going to be a squad controller. Now, I'm not going to do anything particularly sophisticated for how characters are added into the squad. This is something where, that's going to depend a lot upon the particular game, whether you want it to be one squad for all of your AI characters, whether you want it to be something that's more dynamic and it's based upon ones that are adjacent or grouped by type. That's sort of more, a bit out of scope for this, and it's really dependent upon your game. I just want to focus on, once we've got that squad, how can we do this balancing process? So the way we're going to approach this is that squad AI, that squad controller is going to determine whether each individual member of that squad is actually trying to hit you. And what we will do is the ones that are trying to hit you will fire the exact same way they normally would. The ones who are intentionally missing, their projectiles will actually explicitly not be able to do any damage to you, but how they fire will be different. So when they are firing a projectile that is explicitly intended to be one that's missing, they're going to shoot directly sort of either side or around the camera. The reason being is that although they are not actually going to be trying to cause damage and will actually be explicitly unable to cause damage to you. We want that psychological effect of this thing's shooting right at my face. So it's about not having it be actual real gameplay pressure, but creating a level of psychological pressure on the player. So, similar to other ones I'm trying to do with these Dev Toolkit ones, I'm going to try and keep this fairly self-contained and modular. So what I'm going to do is I'm going to set up a script here that is going to be my squad controller. And then this is going to coordinate the characters. So first thing it's going to need to be able to do is it's going to need a list of our squad members. And this is something that could dynamically change as characters are spawned in, as ones maybe move far away or are despawned. We'd be able to dynamically change that. In this case, we're not worrying about that side of things, but again, that's an additional thing that we would need to have in there. So with our members, what I want to add, I want to find objects of type, and I want to find all enemy base ones. Just add them into that squad. So that's going to be the first thing. Now, what I want to be able to do is those enemies, I want to be able to control whether they are trying to hit or whether they are trying to miss. So let's have in an option here. So force miss. This will just give us something where we can control whether we're forcing to sort of hit or miss, things like of that. So, okay, if we are forcing a miss, that's going to change the location we try and hit at. So what I'm going to set up for this is the kind of thing where I'll often use stuff like a property for, because I want different locations. When we're trying to actually miss, I'm going to aim at the head, whereas otherwise I'm going to more aim at a sort of random location or the center of mass for the character. So let's have our aim target, and only needs a getter. So if we are forcing a miss, so what I'll do is if it's a force miss, then what I'm going to need to do is, previously what I was doing here was I was retrieving that transform. What I'm going to have is player base, player, and just retrieve that. Now, this is something where, again, I only have a single target in this, so I'm able to make it very sort of a little bit more hard-coded in terms of it's directly finding the player base. Obviously, in a larger project, there would be systems you would be going through in terms of identifying visible targets, areas like of that. But we just want to focus on that sort of illusion of pressure side. So if we're forcing a miss, then our aim target is going to be the player, and the player has as a head position variable. Otherwise, I'm going to use the player transform, actually player center of mass. So I don't currently have that as a variable. So I'm going to set that up in the player just so we've got a center of mass option for them. Because this might be different depending upon the particular one. So I think good just to have that be something where we can easily sort of determine that. So transform dot position plus, it's typically going to be about that. We could have a transform here for Right, so for that anchor point, so we might as well use that actually. So there we go. We'll be able to retrieve that. What this just means is our weapons look at just can always look at whatever our aim target is. So if we're forcing a miss, it's going to aim at our head. If we are aiming, doing our normal aiming, then it's just going to aim at the center of mass for the player. We can make sure that is set up so that we've got that linked up properly. So it'll just be at the body. So if we run that, now they should just still be shooting largely a bit below the camera, which is what we can see there, that they're shooting below the camera point, which is good. What we want to then do is let's start with, we'll make our squad controller so we can sort of set this option of if it's a force miss or not. So what I'm going to do, this is just for debugging testing purposes, just making sure that that miss mechanic actually works. Force miss. So then for each member in members, member force miss is equal to this. So I just want to make sure that that setting is working, because the other thing we want to be able to do is if we had force missing, then when we launch that projectile, we need to actually tell it that it is not able to actually do damage. So set up here, projectile logic. So we're getting the fire interval there, projectile logic, and we will have a setting here for forced miss or fake projectile. So we can set it to be a fake projectile. So projectile logic, fake projectile, if we are doing a force miss, and if it is a fake projectile, then we just ignore this logic here. So if we are not a fake projectile, and there we go. So what this should mean is when we have our squad set up, so we're going to need to create a game object here for our squad. Okay, so we need to set up the object here for our squad AI. And we'll just position that there, and we'll give it our squad controller. Okay, so with our squad AI in, we can then test this. So we'll let it run, and what we'll be able to see is the vignette's in fully. We're getting the characters aiming at us. Now, if I turn on force missing, then what we'll notice is, well, they're aiming now directly at us, plus also our damage is continually, that we're receiving is going down because we're no longer facing as much damage. And that will eventually drop down to 0 because this is averaging over the last sort of 30 seconds. So, okay, we've got our ability to trigger a force miss there. Well, now we want to work out how do we actually go about doing this. So we've got different enemies here that are able to be doing different damage. We've got 4 different enemy types here. So balancing that can be challenging. So what we can do is we can ask each enemy how much pressure do they apply to the player. And so then the squad AI is looking at, okay, has a threshold. We're allowed to apply this amount of pressure to the player. And then as soon as it goes over that threshold, then we make some AIs force miss. Now we can be a little bit more sophisticated than that in that, well, how do we decide which one's force miss or not? So initially, let's just go for it being a fairly naive setup where we get the pressure and what we do is we just go through the AIs in order and we just keep building up until we hit that pressure threshold. So we'll do that initially, and then we'll look at ways of making that better and making it so that the player can't as easily just know, oh, okay, this is what's happening. So firstly, I want to have a control here, max player pressure. And I'm going to say that that max player pressure is 20. Then the enemies, I need to know from them what is their amount of pressure they can apply. So public float, pressure applied. So how I could do this, there's lots of different ways. And in particular, depending upon the more complicated the behaviors and the range of sort of weaponry and attacks an AI can use, that will actually change things. Similar if you've got ones where, well, this is just a support AI, the way you calculate pressure for it is going to be different there again. In this case, I'm going to do a fairly straightforward calculation where the pressure applied is based on the amount of damage per second, essentially, for that particular one. So what I could do is, and I will actually cache some of this information. So the projectile prefab, get component, and what I'm going to do is store that. And I'll have that up here. Projectile, LINQ projectile. Just so that then this is something where I can query this. LINQ projectile, let's for that. All right, so the LINQ projectile, well, I can get its damage, and then I know its interval. So divided by LINQ projectile, and then its fire interval. So this is going to be the damage per second. So it gives me a way of working out the pressure there. So I'm going to set up a helper function here, rebalance. So what this will do is float current pressure is equal to 0. We go through all of the members and F current pressure plus member and that pressure that it would apply. So if that would take us over the threshold, so if that is greater than the max player pressure, then that member is told to force miss. Otherwise, we update that current pressure based on the pressure applied, and that member is not missing. So what this will allow us to do is as we raise or lower that pressure, that will change the number of enemies that are currently able to fire or not fire. So update who is allowed to fire. So I'm going to have this just happen every frame. And what I might do is also give the AIs a way for them to be able to indicate whether they are attacking or not. So using TextMesh Pro, TextMesh Pro GUI, and feedback label. Because what I can do is with this, force miss, and I'm going to just set internal one behind this, which what this will do, this way then I'm just updating that text only when it changes. So force miss is equal to value. And we can then set, oops, These should have gone the other way around. So here we return force miss, and then here we just update that text, feedback label, text. So if we are force missing, and we put up that, otherwise we put up attacking or hitting. Just so we can see at any point in time which of these are attacking and which ones aren't. It'll just make it a little bit easier for us to be able to do that. So we can then just update our script so it's able to link to that. And that should mean our variants have updated as well, which is good. So that means our player pressure here, we'll see which ones are attacking, and we'll see as we vary this player pressure. So we can see we've got 4 ones here that are currently allowed to hit, 2 ones that are intentionally missing. And we can see we're hitting around that DPS value we were setting. If I lower this now, more of them are now missing. And we'll see the damage will start to slowly drop. If I raise this, then we'll see more of the ones are now hitting us. So, okay, gives us a way of balancing that. We want to have a better option than this, because obviously if we are doing sort of this process where it's a very naive one, if we just go through in order and it's never changing, that's going to be really straightforward for the player to figure out and to know which ones to, are not trying to hit them. So we need to have this be something that's changing periodically. So what I would often do is, rebalance interval is, say, maybe 5 seconds. Countdown to rebalance. So then countdown to rebalance. Update that. If it's time to rebalance, then we perform that. And we also then reset that. So rebalance interval. So we'll be rebalancing every few seconds. Rebalance periodically. So that's good. It's not going to be happening every frame, but it will be happening sort of periodically there. So one of the things we could be doing is checking if a AI is even going to be able to actually hit. Now, in the case of this, all of our ones can hit, but let's set up so that in theory, we'll can hit target. So we'll default it to true, so all of them can hit it, but this is something where if one can't hit it, we don't want it to actually influence the calculation. So we can start to filter out which ones actually apply in this case. Because we could then check, okay, well, if the member, if they can't hit the target, then we just skip them. They do nothing. And we make sure down here, if they can't hit the target, and so we only fire if we can hit the target. That way, when we could hook this into vision systems, things like that. So, okay, if we can't hit the target, then it doesn't get factored into the calculation. So that is going to change a little bit there and improve things. So AIs that might have temporarily moved out of range, things like that, are not going to distort what's happening there. So that's something where we can see our 2 medium ones. One of them is currently hitting and one of them is missing. If I turn this off, then that's going to change which ones of those are actually firing. And in particular, if we see that rebalance happened and then this one is now able to hit. So that's something where we can also If we can't hit the target, we could make sure we update the status there as well in terms of whether we're force missing or not. So that's something where, the update here, if we're not able to hit the target, let's make sure our text is up to date. So I'm actually going to bring this down here. I'm going to change this back now to this sort of setup, just so that it's a little bit easier for me working with it. So what we'll do down here is if we can hit the target, then we check if we're doing a force miss. Just so that we're giving a proper indication there of which ones are in what state. So now we're filtering out things that can't actually hit the target. So that means if I take a whole bunch of these ones, like the two large ones, and I make it that they cannot hit the target, then we immediately see that change, but I want it the back now can. So we get an immediate change there. We're seeing changes in behavior happening, which is good. But again, we can do better, because this is then still a case of, okay, if they can all hit the player, it's still fixed in what's happening. It's not varying or changing anything like of that. So what we would potentially do here is we could set up a list. So enemy base, candidate, attackers. And we do our initial pass through the list here of, we only populate that with ones that can actually hit the target. Now what I'm going to do, I'm going to use LINQ for this. Now LINQ, we do need to be cautious that with LINQ there are performance implications. It's not something where we would want this running every frame. Now this isn't running every frame, so it gives us an efficient way of doing these calculations. Because with LINQ, what I can say is, okay, well, members, I only want the members where, well, firstly, give me the members that can hit the target. So that's the first thing it will do. It will filter and only give me the ones that can hit the target. Then, well, with that, I might also want to make it that it makes sense that the ones closest are potentially able to be hitting reliably. So what I could do is say, okay, well, I want you to order this by, and then we get the, and actually we do this before the to list, we do an order by, let's say member, the member transform position, and I would do a vector3 dot distance from that member's transform position to our transform position. So just organize this a little bit. Let's put that down here. And same with this. So what we're getting is get a list of AIs who can attack and order by increasing distance. Because what we could do then is we could ensure that, okay, well, we always make sure the nearest 2 or 3 are going to try and attack if they can. So let's have, so the num nearest to include, let's say it's always 2. So the nearest 2 we want to try and include. And there are cases where we might want to allow it to go over that pressure threshold. And so this is a case where I would actually do that, where I would say, okay, well, let's bring our current pressure up to here. And, well, let's firstly check. do we have, let's grab first few ones. Index is up to num nearest to include. And actually this, we'd also say, and index is less than candidate attackers, just to make sure that we're we had only one attacker, still going to be able to balance okay. So what we would do is these, we actually just say with these, they have to be able to hit. So candidate attackers, index, force miss is false. They must be able to attack. So then we add member.pressure, oops, that. And then we would remove them from that list. Candidate attackers, remove at index, and we just subtract from index so that we can then, the loop will operate correctly. Add in the nearest attackers. So we do intentionally allow this to bypass those normal pressure limits. So there is a limit of how much it's going to go over, but it just allows us to have it ensure that nearby ones that the player is most likely to attack are a genuine threat. Because the player is likely going to go for the closest one, so we want that to obey sort of what they'd normally expect. But then now what we can say is, okay, well, while candidate attackers count is greater than 0, so while we still have ones able to attack and current pressure is less than max player pressure, then I'm going to pick a random one. I'm going to grab a random attacker. So random index, random range, 0 candidate attackers count. Then what I want to check is candidate pressure. So I want to know if this is going to go over the threshold. F, that candidate pressure, let's fix up our naming here, plus current pressure. So F current plus candidate goes over max player pressure. Then we don't actually use this one, we get rid of this candidate attacker. Candidate attackers, remove at. We just remove it from the potential pool because we know that we don't want to leave it in there and potentially pick it again because we know it's not going to be a viable option. From attackers. We do need to make it that this one is told to force miss though, so let's make sure we're doing that. So candidate attackers, random index, force miss is true. Otherwise, we tell it that it can attack. And we update the pressure, so current pressure. And we add in the candidate pressure there. Alpha attack. So we'll pick a random one. What this will mean is every few seconds it will cycle who's able to be attacking. So that looks pretty good. The remove we also need to do here. And actually what we can do is that remove can be a constant thing there that happens with all of them. And then this just happens here and an else. So what we're doing is we make the nearest couple of ones attack. Then beyond that, we add in a set amount to build up to the pressure threshold, but we randomly cycle who's allowed to attack. Pick random members to attack. based on pressure. And so every 5 seconds it will cycle and it will change, but the player will be able to assume that the ones nearest them are always the immediate threat, which is good. That's what we want. So now at this stage, all of them are currently attacking. So if we take a look, the current pressure plus the candidate pressure goes over, then we force that one to miss. So it has done a rebalance, but all of them are managing to attack. So if we take a look at our logic here, current pressure is set to 0. We are adding in the one for the nearest couple of ones. And so because we're subtracting index, that means all of them are actually going through this. So that's very much not what we want to actually be doing there. So what I would do in this case is we don't do the remove at that point. What we do is we do candidate attackers, remove, and I could remove a range, so I can remove from starting at 0, and I remove a max. Actually, no, it would be the minimum of num nearest to include and candidate attackers dot count. So at most I remove 2. It's one thing to be careful of when we're doing removals in a loop. It's very, very easy to have a scenario like of that. So this should mean that we now have a couple of the ones are hopefully missing. So we're still encountering that. We are removing those from the candidate attackers. So what we can do is we can just check and see what's happening with this. And we do encounter the bug with this where when we are on the main thing there, we need to, for whatever reason, have to do this with Unity. Now we have the proper launch JSON, and then we can actually attach to this and see, okay, well, we have got a current pressure of 8. So index went up to 2. We can see with candidate attackers, we should at most be removing 2 from that. So candidate attackers should go down to 4, which it does, which is good. So we can then see we pick a attacker from our list. We get the pressure. So you can see this would apply a pressure of 4. And that doesn't go over our limit, so it's able to include it. Then we come back around again. We've now got a pressure of 5 being applied, so that's able to kick that in. Now we get another one where it's candidate pressure of 5, current pressure is 17, so we can check that. We'll go over our max player pressure. So that means we tell that particular one to force miss. And we remove that one. And then we go through and the next one is going to be the same. So we should have 2 that are force missing. So we can see we've got 2 of the ones here that are currently missing. And that should actually change each time we run with this. You can see different ones are missing each time. And so every time it re-updates, different ones will actually be missing there. But our nearest 2 ones are always missing. Well, are sometimes able to be missing, which is not what should be able to be happening. Because we should be sorting by the distance from... we should not have been sorting from that. We should have been sorting these with respect to their target. So we would need to be tracking our target. So this is something where the squad controller will often do the assigning of targets as well. So in this case, the player, I currently retrieved that here in the particular enemy one there. What I could be doing with this is I could make this so that I'm also retrieving this down here. So squad controller, target, and then we use the target's transform position. And so now the nearest ones will always attack, but it will balance out within the ones farther away will not. So the whole process of assigning targets to a squad is actually a separate area, and that's something where you need to pull information based upon who in the squad's able to see the different things. So now we can see the nearest one there's managing to hit, but we're providing this sort of balance. And if I drop this down to 10, then we're going to have a couple of ones are still managing to hit. If I drop this down even lower, then once it rebalances, we should see even more ones start missing. So we could see they're not properly changing there with us dynamically changing that. So one of the things we want to make sure of is when we're going through this, any ones that we leave in the candidate attackers, because we could potentially go through this and not actually be able to pick any ones here. So remember, in candidate attackers, we just need to force them to be missing. This just allows us to really lower that player pressure, and it'll be able to adapt correctly to it. So we're running. Let's drop this down to 5 and see most of the ones are now missing, but the nearest two are still able to hit. If we go up to 10, it's going to be about similar because we were already needing that with what we were doing. If we jump this up to 30, then that will allow a lot more ones to hit, and we can see the intensity is much higher there. And what this means is with setting that to say 10, and I'm going to drop this down like this. If I take all of these enemies and let's just chuck in a bunch more of them. Because it allows us to do stuff like this, where these are able to become way more threatening without us needing to, change balance settings, things like that. So we can have this. So we're now facing a lot more enemies that are going to be able to be shooting at us. And so that we can see our damage per second is reined in a lot more. Most of these are actually missing us, but it very much does not feel like that. The player pressure is still being able to be kept quite low. If we drop down the num nearest to include, so only one of them's allowed to hit, we can see only this one here is actually hitting us now. If we ramp that up to like the nearest 5, then when it goes and does the rebalance, we've got a lot more hitting us. And it's going to be able to exceed that pressure threshold. If we ramp the max player pressure up to, say, 30, and we can also shorten the rebalance interval, because the rebalance is going to change. You can see really frequently who's able to be attacking us there. And we don't want that to be too rapid though, but that does give us a way of being able to manage and balance this. So now from the player's point of view, it feels a lot more intense So we've got way more enemies here, feels way more intense, but it's actually not. And if I turn off the squad controller, then we'll be able to see, because with that off, they're all attacking the player. And so we're getting pretty high damage per second there. So sitting at around sort of 60 per second. But as soon as that squad controller is present, that starts to pull back down, but it doesn't feel any less threatening. And that's a key thing with a lot of stuff with AIs. Our focus with AIs is not always about having it actually be more dangerous, but can make it that it feels more dangerous. And so in terms of where they aim, if I get rid of, don't need quite that many, because we can also tweak this a little bit where what it does when it gets that aim target is it actually picks a spot a little bit either side of it. So we could have a little bit of random noise around that. So we could have a new vector 3, random range, minus 0.1, 0.1, and just do this for each of its particular ones. That's going to mean that there's a little bit more variation there. The one that I generally used to use was making it do it would shoot at either the left or the right ear. Tends to work pretty well. This way they're not going to be all hitting at the exact same spot. So if we do this, then we'll just get a little bit of variation there. So they're all currently going to be hitting. And then they will change with me turning that back on. They will have a bunch of ones missing, and so those will be shooting around essentially the player's face. So creates that feeling, that illusion of pressure, but as we can see from the vignette, it's actually far less pressure than we were under. It's a third of the pressure, and regardless of our squad composition, the player will be under a similar amount of pressure. And that's the goal of this, is that we can focus on designing an interesting encounter based upon composition, and every time we rebalance the stats for an AI, we don't necessarily need to go and heavily rebalance the encounters, because we've got a level of AI happening in terms of who's able to attack, to control, to curate the experience for the player. And that pressure value is something we could vary. So we could have, at different stages of the game, we could lower that pressure, we could raise it really high, and that would allow us to control the experience more closely for the player. We could also have different intensity settings just overall for the game, so that if someone's playing on a lower intensity setting, you have a lower pressure there, which means it's going to be easier and less overwhelming for them, and then you could ramp that up. You could also change it dynamically based upon how well the player is doing. If the player is doing really, really well, ramp up the pressure setting so that they are under more threat. If they're doing really poorly, lower it. So it gives us that curation, that control over the experience. And the key elements of how we did this were we had a squad AI controller, which the squad AI controller is aware of all the AIs in that squad. How we determine which ones are in that is going to depend a lot on the setup and the architecture for our game. It might be all ones for a particular type, it might be ones within a radius, doesn't really matter. It's specific to our game. But either way, the squad knows what AIs, what things it's controlling, and then it decides which things are allowed to attack. We have a minimum number of nearest ones that can attack. That ties into player expectations, that the things closest to them are going to be the largest threat. So they'll tend to prioritize that. So we want that prioritization to have gameplay payoff, that targeting that nearby one actually works out for them. We also then randomly pick outside of that. So that way then the player can't always predict who's necessarily attacking them and who's not. So it keeps them on their toes because it's constantly shifting. we're filtering out who's able to attack. So at that particular point in time, if an AI can't, then they don't distort calculations for the squad. So then the AIs themselves tell us how much pressure can they apply. Now, for a simple AI with a single weapon, single attack, that's going to be a fairly straightforward calculation. That might be a more complex calculation for AIs with more nuanced behaviors, and that might be something where that's a specific tuning setting that you actually adjust. But it allows us to control the behavior there, and not just of the firing here. Because we could also use this for melee enemies, controlling who's actually getting in really close to the player and trying to attack, and who's potentially hanging back. That could be done via this sort of setup. And so you can link this into the behaviors of having one start to engage or disengage from combat. When one's force missing, it could be attacking more from cover, or it could be using that as a way to reload. There's lots of different things we could be doing there. But the key is, this allows us to control and curate the player experience and makes our process of balancing the game a lot easier and gives us a better experience for the player. So dive in and experiment with this. It's set up as a fairly modular thing, so you can plug this in somewhat into existing projects, and you could experiment with this. Tie in some other stuff here in terms of looking at, okay, well, what if we did have different types of attacks? What if we did want to tie in some vocalizations or behaviors or things like that? Look at different extra things you could do there and see the kinds of stuff you can create. But dive in and experiment. Thanks, folks. If you're looking for the code for the project, then in the description below, you'll find a link to the GitHub. And on the GitHub, I've got the code for this project and for all of the other projects. They're freely available. And if you have found the video helpful and you'd like to support the channel, then throwing in a like or subscribing is always a huge help. If you're looking for further ways to support, then I do have a Patreon set up, and that's going to help me keep managing to do these videos for a long time to come, which is going to help more people make cool things. And that's awesome, because that's what this is all about, is helping more people make more cool things. And that is all. Thank you.